Welcome to Definite Integrals Part 2, Disk and Washer Methods. A method to find the volume of a solid that's revolved about a line. And I guess the best way and easiest way to show you is to show you with something I found online. So here it comes. Alright, what we have here is we've got a top function f of x, and we got a bottom function g of x. And what we're going to do is we're going to take that region bounded by those two from A to B, and we are going to revolve that region around an axis, a line. That line in this particular example is the x-axis. And when we do that, we're going to make a solid. So let's go ahead and look at it. When we rotate that around the x-axis, we make a solid. Pretty cool, huh? There is that solid. And now we can even make it so we can see on the inside. We can actually even look through it if we wanted to. Okay? And each one of the cross sections of this thing, if I took a knife and sliced it, I would make washers. Depending on the function, it might make a solid circular disc or a circular washer like we have in all these. So we're going to teach you how to do the calculus to find the volume of this solid. Let me show you one more example. Alright, this time, this is the function. This one is drawn in 3D space, and we're going to rotate it about this line right here, which looks like it's about y equals -1. And when we rotate it, revolve it, we make it into a solid. And if you took cross sections, they would all be washers. Okay, let's look at another example. Same thing. Okay, this time we've got another function, and when we revolve it around that line y equals -1, we make a pretty cool picture there. And that's what we're going to do. Alright, let's go back to our lesson now that you see kind of what's going on where we're revolving around an axis. Now, when we revolve about a horizontal line, we're going to use the multiplier pi. Hey, my pen's supposed to be on. Multiplier pi out in front of the integral. This L stands for from the left. The R stands for to the right. T of x means the top function. B of x, that will be the bottom function. And C is the axis of revolution. Now, if it's revolved about a vertical line, it's going to be again the multiplier pi times the integral from bottom to top. So B equals bottom, T equals top. Okay, R of y is the right function of y. And that means it's going to be x equals some function of y. And then the L of y is going to be the left function. Nice spelling. Why, thank you. Of y. And again, that's going to be some equation, x equals some function of y. And of course, C is going to be the axis of revolution. And that will be a vertical line, x equals something. All right, let's move on to our first example. See what's going on here. Okay. Find the volume of the solid obtained by revolving the area bounded by the x-axis, the y-axis, and the graph of y equals -1/2 x. And we're going to revolve that around the x-axis. And when we do that, we're actually going to make a cone. The volume of that cone equals 1/3, okay, times pi. The radius of that cone is 1. And the height of that cone is 2. So the volume equals 2 pi over 3 units cubed. Alright, let's see what's going on there using the calculus. Alright. What is the top function? That would be 1 minus 1/2 x. The bottom function is y equals 0, also the x-axis. The left bound is 0. The right bound is here right at 2. And the axis of symmetry is 0. So it will be the integral from left to right of the top function 1 minus 1/2 x minus the axis of revolution, quantity squared, minus, okay, the bottom function, 0, minus the axis of revolution, quantity squared, dx. So that will just end up being the integral from 0 to 2 of 1 minus 1/2 x quantity squared dx. So all those will just be zeros and squared and zeros. Alright, you can either square this out and get 1 minus x plus 1/4 x squared, sorry. Okay, that's when you square 1 minus 1/2 x, integral from 0 to 2 dx, or you probably could have used substitution as well. So that would be x minus x squared over 2 plus, let's see here, 1/12 x cubed, evaluated at 2 and 0. So 2 minus 4 over 2 is 2 plus 2 cubed 8 over 12 minus 0 minus 0 plus 0, 8/12. And we already knew, oops, I forgot to multiply by pi, you guys. Pi times that integral, so pi times 8/12, which again is 2 pi over 3, which we already knew was volume. Alright, let's try the next one. Find the volume of the solid of revolution which results from revolving the region enclosed by y equals Okay. Negative x squared plus 6x plus 1 and y equals 7 minus x around the line y equals negative 3. Top function is the quadratic. So negative x squared plus 6x plus 1. The bottom function is 7 minus x. The left bound, you're going to have to figure out where those two intersect. And the right bound, you're going to have to set those equal to each other to find out what those two equal. The left bound will be 1 when you solve, and I'm not going to do the math here. And just set these two equal to each other and solve that quadratic. The right bound is 6, and the axis of symmetry is negative 3. So the integral setup is pi times the integral left, okay, 1 to 6. Top function, negative x squared plus 6x plus 1 minus a negative 3, so plus 3, that quantity squared, minus, alright, let me extend the page so my face doesn't get in the way, minus, okay, the bottom function, 7 minus x, this is all has to be in parentheses as well, minus a negative 3 plus 3 quantity squared dx. There is the setup. It's going to take a little bit of work for you to actually figure out what that is, and I will let you do that on your own as best you can. I'll tell you what the answer is in a minute. Hold on. That answer is 375 pi. And here's your last example. Find the volume of the solid which results from evolving the region bounded by the x-axis, the y-axis, the line x equals 2, and the line y equals x plus 1. So there are two regions formed. We're going to try to set up the boundaries and everything for the first region, B, and then for the second region, A. Alright. So what I'd like you to do is I'd like you to fill out the right-hand function of y, the left-hand function of y, the bottom value for B, the top value for B, and the axis of revolution for B, and then the same for region A. I would like you to fill those out right now. Pause before you do. And here are your values, and we'll make you set up the integral in a minute. Notice that my left function here is y minus 1. The original function was y equals x plus 1. We need to solve for x because it's a vertical line that we are revolving around, so we change it to what we solve for x and got y minus 1. Alright, let's set up both integrals. So go ahead and set up both integrals for region B and region A and check your answers. And we are going to, here are the two integrals set up. And we'll add those two volumes together. And when we do, we get an answer of dun 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 of 28 pi over 3. Now, I do have one more thing to say, but I have to probably explain it in class. But what happens when you've got a function, okay, top function and a bottom function, and you got the area in between, but your axis of revolution is above or more positive? Yeah, we'll talk about that in class tomorrow. Remind me to tell you. This does conclude Definite Integrals Part 2, Disk and Washer Method.